Mid-floor, end-of-terraced and mid-terraced apartments can be made compliant with Part L1A fairly easily using the Foresight system. We import the detail of the project. We will use the timber frame method of construction. It is an apartment, no flat roof, an apartment above the ground floor level. Because this is timber frame, the intermediate floor is timber. ACDs are no longer sufficient if the new fee standard is to be achieved. We need to use robust or enhanced details. It is a mid-floor apartment, end of terrace, and the dwelling is a mid-floor apartment. Because the dwelling is mid-floor, there are not as many construction joints as would be found in ground floor and top floor apartments, making compliance less difficult. This project has 2 exposed elevations and there is a small volume with these apartments. Compliance is also made difficult by contemporary apartment design which has a lot of glass, and this can cause overheating. We've collected the dimensions required by SAP and the thermal bridge calculator. Let's design the Part L1A specification. Before we start into the design process, let us look at thermal bridge. As you can see, it is really good, less than 0.03. This is because there are very few construction joints and exposed areas in relation to volume with this type of apartment. The recommended Y factor is 0.05 when designing to the 2013 regulations. Let's go back to the first part of the specification to be designed, the wall. When designing a Part L1A specification using the Foresight system, the user chooses a performance level to design to, in this case the 2013 regulations. The designer chooses the structural materials and insulation materials to use, and the software calculates the appropriate depths of the insulation. The software calculates the U value to be R433 and is used by SAP in the calculation of the performance of the dwelling. Because this is a mid-floor apartment, the flat ceiling, slope ceiling and flat roof does not need to be designed. The areas not to be designed are locked, and the designer simply clicks on save and it automatically takes the user to the next part to be designed. The windows. The designer chooses the 2013 standard. 2 choices will be presented. Generally speaking, the better U value of 1.4 should be taken when designing apartments. The doors and roof lights do not need to be designed in this particular project. The thermal bridge is very good, as we have discussed earlier. Air permeability. The user chooses the 2013 standard and the software will give 2 good options. It is our advice that the designer chooses the 5 air exchanges. Anything less than 4 will require a heat recovery system. Heat recovery systems suitable for small dwellings are not common, and this is why apartments should not be designed to an extreme fabric standard. This is something that the industry needs to look at. Ventilation. With the air tightness chosen, we can use natural ventilation. Lighting should always be 100% energy efficient. Stoves as a secondary heating source are not suitable for apartments, and a none option should be taken. Solar panels are not suitable in apartment design, and a none option should be taken. Hot water storage. Combination boilers are most suited to apartment design and requires no tank. We are working on the option of introducing a community heating system, and we hope to have it in place fairly soon. Water usage. A none option should be taken with water usage for apartments. Boilers. All our boilers have an efficiency of at least 90%. Heat control is now becoming very important in the design of part L1A, and we are using a delayed start thermostat and programmer. All the design decisions have been made. Now let's see if we are compliant with the 2013 regulations. As you can see, there is non-compliance in the DER and TFE, but it will take very little to achieve design compliance. So let's go back to the design process. When we look at the design options, we are very limited in what we can do. We cannot improve any element of the fixed building specification because secondary heating systems, stoves and solars, and heat recovery systems are not suitable for apartment design. So we'll have to look at the fabric for design compliance. The cheapest and only option is to increase the performance of the wall. And we simply choose the fee standard and click on save. Increasing the insulation to the wall to the fee standard achieves both DER and DFE compliance. From our experience, the fee standard is as high a performance as can be achieved with apartments and with the technology that is readily available. We do not offer extreme fabric design option with apartments because heat recovery systems required for extreme fabric design are not suitable for apartments. Apartments are hard to make compliant with part L1A, but mid-floor apartments are less challenging than ground and top floor apartments.